Your rate provider goes down at 2 in the morning. Does your API go down with it, or quietly switch to the backup and keep answering? That is one router. But it has 3 traps. It costs latency you did not budget for. It hides the real error, and it will happily fail over an operation that should never be repeated. Real project. Real screen. Every field explained. This is a real flow. Open in Anypoint Studio. It fetches an exchange rate, built so a dead vendor never takes the API down with it. 3 routes are stacked inside the router. Hold on to this. Those are not branches, they are attempts. Mule tries the first. Only if it fails does it try the second. Front of the flow. I've marked the listener's path field down in the Properties panel. /API/v1/rates. An ordinary get endpoint. The component itself is the first icon on the canvas. Then a set variable called capture currency. Name is currency. Value reads the query parameter with a default of USD. Why lift it into a variable here? Because all 3 attempts need the same input, and reading it once means all 3 attempts are working from exactly the same value, even the third one, which never touches the request at all. And here is first successful. I've marked the whole router. 3 routes inside. Primary vendor, secondary vendor, and a cache fallback. On a healthy day only the top route ever executes and the other 2 are dead weight on the canvas. Route 2 runs only if Route 1 threw an error. Route 3 runs only if 1 and 2 both threw. Now look at its properties panel, because this surprises people. Display name, and that is the complete configuration of a first successful router. No timeout, no retry count, no delay between attempts, no condition. If you want retries with a wait in between, that is until successful, a different component entirely. Attempt 1, marked here, is 3 components, a logger, the HTTP call to the primary vendor, and a set variable that stabs which source answered. While the primary is healthy, this route serves 100% of your traffic. That is worth saying out loud, because it is the clearest difference between this router and round robin. Open a request inside it and there is nothing router specific at all. I've marked its configuration field, rates_primary, and underneath it Studio resolves the full address. This is the component whose failure decides whether attempt 2 ever happens. And this is the logger at the top of attempt 1. I've marked its 2 fields. The message says attempt 1, primary, and carries the correlation ID. The level is debug, on purpose, because attempt 1 succeeding is the boring, normal case and you do not want it filling your production logs. Attempt 2, same shape, different vendor, but watch the logger. The message now says secondary, primary failed, and the level has moved up to warn. That single field change is the whole monitoring story. The moment this line appears in your logs, your primary vendor is down and you are running degraded. Attempt 3 moves it up again, to error, and the message says both vendors failed. Debug, warn, error. Climbing with each fallback. Copy this pattern. It costs you 3 minutes and it is the difference between knowing you are degraded and finding out from a customer. And notice what attempt 3 actually is. Marked here, it is not an HTTP request at all, it is an object store retrieve, pulling the last known good rates out of a cache. A route can be any component. Your final fallback does not have to be another vendor, it can be stale data, a default, or a queue you drop the request onto. The last component in every route is this set variable. In attempt 3 it writes rate source equals cache. Attempt 1 writes primary. Attempt 2 writes secondary. Because it sits after the risky call. Only the route that actually succeeds ever reaches it, so this one variable tells you exactly which attempt 1. And here is the payoff. In the transform message at the end, I've marked 1 line of real data weave. Degraded equals rate source not equal to primary. 1 boolean in the response body that tells the caller, honestly, whether they just got fresh data or a fallback. Without this, a silent failover is indistinguishable from a healthy day, and you can surf stale rates for a week without noticing. The single most misunderstood thing about this router, attempt 1 gets the payload that entered the router, and fails. What does attempt 2 receive? Not attempt 1's half-finished output, the original payload again. The exact event the router started with. Every attempt begins clean, as if the previous one never ran, and afterwards the payload is whatever the winning attempt left. No wrapper, no record of what was tried, which is exactly why you need that rate source variable. Variables follow the same rule. Anything set before the router is visible to every attempt. That is how all three routes read vars.currency. Anything an attempt sets before it fails is thrown away with it. Only the winning attempt's variables survive. And look where the set variable sits in each route. Last, after the risky call. If it's set first, every attempt would stab its own name before finding out whether it worked. Two things worth memorizing. If every route throws, the router raises composite routing, and the error object carries what each attempt threw, so the real causes are still recoverable. The second one bites. This router catches every error a route throws, including errors you raised yourself. A validation failure inside attempt 1 does not stop the flow, it silently promotes attempt 2. Keep your routes narrow. One risky call, nothing else that can throw. This trap shows up as a production incident, so let's do the arithmetic. Gather runs its routes together, so its latency is the slowest single route. First successful runs them one after another, so on a bad day its latency is the sum of every attempt before the one that worked. 3 vendors on a 10-second timeout is a request that takes 20 seconds to reach the cache. Your caller gave up long ago. Set aggressive per request timeouts 3 seconds, not 10. The comparison table. Read the first row and everything else follows. Gather runs every route. Choice runs 1 by your condition. First successful runs them in order until 1 works. Round robin runs 1, rotating. 2 rows deserve a second look. Latency, the slowest single route versus the sum of everything tried. And traffic share. First successful sends everything to route 1 while it is healthy, the exact opposite of round robin. Now the important half. Not for retrying the same endpoint. 1 attempt per route is all you get. Not for spreading load, because route 1 takes everything until it breaks. Not when the decision is about your data, that is choice. And here is the one that causes real damage. Never fail over an operation that is not safe to repeat. If a payment times out, you do not know whether the card was charged, and failing over can charge twice. Reads and lookups. Yes. Writes and payments, only with an idempotency key. Naming. The router gets the outcome, not the component. First successful : rate provider failover. Each route's main component gets its position. Primary rates provider, secondary rates provider, last known good rates. Now the fallback order reads straight off the canvas. 1 variable for the winner, rate source, and put the attempt number in the log message, because at 3 in the morning, attempt 2, secondary, primary failed as a complete sentence and logger 1 is not. The habits. Bad side. No per request timeout, so a hun vendor blocks every attempt behind it. Every route logging at the same level, so a failover looks like a normal day. Fat routes where anything can throw and trigger a pointless fallback, and no signal in the response, so nobody finds out. Good side. A tight timeout on every request config. Log levels that climb with each fallback. 1 risky call per route, and a degraded flag in the response body so monitoring can alert on it. 4 things worth knowing before you ship. It is not a retry 1 shot per route, and the same endpoint tried again after a pause is until successful. The last route should be something that basically cannot fail, like a cache read, because if every route throws you get composite routing and no answer at all. Order routes by cost as well as quality. A cheap reliable source stock last costs you 2 timeouts every time. And unpack the composite error in your handler, instead of logging 1 useless line. 5 to answer without thinking. When does route 2 run? Only when route 1 through. What payload does route 2 receive? The original router input. Every attempt restarts clean. All of them fail, composite routing, and the error carries each route's cause. Is it a retry? No 1 attempt per route. And versus round robin, failover versus load spread. Everything goes to route 1 while it is healthy. That is first successful end-to-end. Tight timeout on every request. Log levels that climb with each fallback. A last route that cannot fail. The winner stamped into a variable, and never pointed at an operation you would not want run twice. Next, round robin, the router that looks exactly like this one and does the opposite job.